All right, let's hit the slopes.
Hold on, big guy. Some of these slopes look steep. I have a feeling it's all downhill from here.
Actually, Olive, we've got to go up on the ski hill lifts before we start going downhill.
It was just an expression, but look at that straight section of the ski lift. Even that looks steep.
This should help you feel more comfortable. I took a picture of the lift and put it on a coordinate grid so that we can model the slope of the lift.
Okay, everybody freeze. Are we talking about ski slopes or the slopes of lines?
Both, man. We can model the steepness of different ski slopes with lines having different slopes.
That's so nice, Gio. Understanding the math actually might help me feel more comfortable.
Great. We can find the slope of this line using any 2 points of the line. So, take a look at the chair hanging from point 4, 2, and the one hanging from point 6, 3. The difference between the y coordinates is our rise. The difference between the x coordinates is our run. The rise and the run and that line segment form a triangle. And we can use the triangle to find the slope of this section of the lift.
Rise, 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 overrun. Use the triangle to find the slope of the line.
You know it. The rise is the length of the vertical leg of the triangle, which is the change in y values. The difference is 3 minus 2, so the rise is 1. The run is the length of the horizontal leg of the triangle, which is the change in the x values. The difference is 6 minus 4, so the run is 2. The slope of the line is 1/2. See, Olive? The ski lift can be modeled by a linear function with a slope of only 1/2. That's not that steep.
No, I guess not.
Hang on, Gio. I was thinking of the triangle between these two chairs.
Azul, it doesn't matter which points on the line you choose. The ratio of the rise to the run will always be the same. And the triangles will be similar.
Huh?
The ratio of the rise to the run for all these triangles will always simplify to 1/2. Choose any 2 points on a line. You'll always get the same slope.
Oh, I got it. Cool.
Check out that lift. I'm not going on that one. No way.
Hey, you never know, Olive. By the end of the day, you might be up there with us.
Oh, man.
What's the matter?
I took a photo of this lift too and put a grid on it. And I had almost all the labels on when I deleted the grid by mistake.
Haha, your grid went off the grid. Well, like Olive said, just find the slope using the smaller triangle.
Yeah, but what I really wanted to know is the height difference between these two chairs, the height of the larger triangle.
No problem, because these are similar triangles formed by the same line. We know the ratio of the rise to the run of the two triangles will be equal.
Oh, so I just need to set up a proportion comparing the rise over the run of the smaller triangle to the rise over the run of the larger triangle?
Right.
Which proportion can we use to find the value of y?
Way to go.
Use the proportion to find the value of y. Way to go. To get y by itself, we can multiply both sides of the proportion by 16. When we simplify, we see that y equals 12.
Okay, now that we've talked about the slopes of lines, can we please hit the slopes for skiing?
Hey, wait a minute. What's that sign?
That's the trail map. Pretty tight, right?
What's cool is this graph that models the average steepness of the trails.
Well, I guess the green one doesn't look too bad.
The green trails are the least steep.
Yeah, I get the math. The slope of the green line is less than the slope of the other lines.
Right. Check this out. It says the red line representing the double black diamond trail has an angle of 45 degrees.
Oh, this one time in math club, we talked about how a 45, 45, 90-degree triangle is an isosceles triangle. So the rise and the run are equal.
And when both values in a ratio are equal, the ratio is equal to 1. So the slope equals 1.
And as you can see, the y-intercept is 0. So the equation for the red line is y equals x.
Here, let me graph y equals x on my calculator.
Hold up. You brought your graphing calculator?
Don't worry, it's no proof.
Let him finish, Azul. He's doing this for me.
The red line has a slope of 1. As the slope of the line decreases, the line gets less steep.
Yep. Look at how the coefficients of x in the equations are decreasing. That shows us numerically how the slopes are decreasing.
Exactly. And as the line gets more steep, the slope increases.
Here, the coefficients of x are increasing, just like the steepness of the line is increasing.
Just like the line to the ski lift is increasing.
Shush with the sarcasm. We're on a roll here. And get this line has a slope of positive 1. But if the line has a slope of negative 1, it looks like this.
Whoa, how do you get a negative slope?
A negative slope just means that there is a negative rate of change.
Huh?
In other words, as the x values increase, the y values decrease. Watch the coordinates of the points. As the x values get greater, the y values get smaller.
Oh, I think I get it. Let's look at another graph with a negative slope.
Yep, here's the graph of y equals 2x. And here's the graph of y equals negative 2x.
Okay, now this is making sense.
So, the graph of y equals negative 5/10 x will look like this.
Okay, but to make me feel a little better, can we take another look at the equations for the ski slopes?
Sure, here they are.
Okay, so the equation for the graph of the double black diamond slope is y equals x. What about the other ones? Match each equation with its graph. Use the graph of y equals x, shown in red, to help. Yeah, that's it. Yeah, that's it. Yeah, that's it. Okay, so we know the red line represents double black diamond trails, and the equation is y equals x.
And we just matched the equation y equals 5/10 x to the black line for the black diamonds trails.
So a double black diamond trail is steeper than a black diamond trail.
Right. Even I don't usually go on double black diamonds. Maybe you'll feel best on these green trails.
Good plan. That line is the least steep. So the equation has to be y equals 2/10 x.
And the blue line has a slope between 5/10 and 2/10. The equation y equals 4/10 is a good estimate for the blue line.
And we know the slope of the extreme line is greater than 1, so the equation for that line must be y equals 2x.
Yep, the dotted line has the greatest slope.
Why is that type of ski slope called extreme?
The extreme slopes are about the steepest you can actually ski down, but only if you are super experienced. And speaking of the slopes, can we please go get our lift tickets now?
I'm almost ready, but all these equations remind me of what we did in math club yesterday. Here, let me show you.
Okay, as long as it's helping you relax. But let's try to finish before spring hits and the snow starts to melt, huh?
I know. Look, at math club, we showed y equations of lines through the origin are in the form y equals mx, and equations of lines not through the origin are in the form y equals mx plus b. Check it out. So, first, draw a line through the origin. Choose a point on the line and label it x, y.
Okay, I'm with you.
To find the slope, we put the change in the y values, which in this case is y minus 0 or y, over the change in the x values. Here, the change in x is x minus 0 or x.
So the slope of the line is y over x.
Yep, and we represent the slope with the letter m.
Okay, so now we have the equation y over x equals m.
You got it, and to get y by itself, we just multiply both sides of the equation by x. Simplify each side, and we get y equals mx.
I knew this line would be in the form y equals mx because it represents a proportional relationship. But I didn't know how to show it using algebra. Now that's cool.
What about the lines that don't go through the origin?
Well, we know this line is in the form y equals mx, right?
Yeah,
And a line that does not go through the origin will either shift up or down a certain amount, right?
uh-huh.
So let's just say that the graph shifts up b units.
So instead of crossing the y-axis at the origin, the line will cross the y-axis at 0b?
Right, and the y value of the point, xy, will increase by b units too. The x value stays the same, but the y value increases by b units. So this point is x, y plus b.
So basically, every y value will increase by b.
Exactly. And since the y value is equal to mx, we can represent this by adding b to the mx.
So, when a line doesn't go through the origin, the equation will look like y equals mx plus b.
Yep, m still represents the slope, and b represents the y-intercept, the y-coordinate of the point where the graph intersects the y-axis.
In other words, the y-coordinate when x equals 0.
Exactly. Actually, even lines through the origin can be written in y equals mx plus b form. The value of b is just equal to 0. We just usually don't write it.
So that means that y equals mx is just a special case of y equals mx plus b.
Exactly.
Okay, so that is pretty cool. But can I remind you that we're here to ski and we don't even have our lift tickets yet? Let's go!
Yes.
Yes. Hey, look, you can take lessons, Olive.
I'm on for that. How long do you think I'll need?
Hard to say. How much do you want to spend?
Well, it depends on how much everything costs altogether. I know. I'll model the cost with an equation.
Which equation represents the total cost, y, for x hours of student ski lessons? Right. The total cost, y, is the cost per hour times the number of hours. So the equation is y equals 20x. That makes sense. This equation represents a function between cost and the number of hours of lessons.
What is the slope of the line y equals 20x? Right. In a linear equation, the slope of the line is the coefficient of x. Here, the coefficient is 20, so the slope is 20. What is the y-intercept of the line y equals 20x? Right.
When an equation is written in the form y equals mx plus b, b is the y-intercept. The equation y equals 20x is just a simplified form of the equation y equals 20x plus 0. So 0 is the y-intercept.
Gee, I thought of it another way. I know that y equals 20x represents a proportional relationship, so the graph is a line through the origin, which means the y-intercept is 0.
Okay, so if I want 3 hours of ski lessons, my total cost for the day will be 20 times 3, or $60.
Actually, Olive, you have to buy a lift ticket too.
Yep. Think of it as your initial cost.
Okay, so let me adjust my equation.
Which equation represents the total cost, y, for X hours of student ski lessons and a lift ticket?
Right.
We know the equation for the cost of X hours of lessons is y equals 20x. We add the cost of a lift ticket, which is $30. Think of the cost of the lift ticket as the initial value in this situation. So the equation for the total cost of lessons and a lift ticket is y equals 20x plus 30.
What is the y-intercept of the line y equals 20x plus 30? Right.
When an equation is in y equals mx plus b form, we know that b is the y-intercept. In this equation, b is 30. So 30 is the y-intercept.
We also know that the graph of y equals 20x plus 30 is a line with a slope of 20 that crosses the y-axis at the point 0, 30. So, just by looking at the equation of a line, we can find the slope and the y-intercept of the graph.
Yup, the coefficient of x tells us the slope of the line, in this case 20. The amount we add to the x term is the y-intercept.
Right, and just by looking at the graph, we can figure out the equation of the line. To write an equation in y equals mx plus b form, we need the slope and the y-intercept. To find the slope, we find the rate of change between any 2 points on the line. Between 1, 50, and 3, 90, the change in y is 40, and the change in x is 2. So the slope of the line is 20.
So we have part of the equation for this graph, y equals 20x. The graph intersects the y-axis at the point 0, 30. So the y-intercept is 30.
So, we can write the equation of a line if we have its graph. That's pretty chill.
Okay, it's time to hit the slopes. And I mean ski slopes this time. Ready, Olive?
For sure. Thinking about the math we can find when we're skiing calmed me down a lot. Thanks, Gio.
No prob. Hey, Azul, let's start with... Azul? Hey, where'd Azul go?
And Azul already fell. Maybe he should have thought a little more about slope.